Here we are going to look at the different types of data analytics. Here we are going to look at the different types of data analytics and its respective questions addressed by it. For our subsequent discussion, we will focus on an e-commerce company scenario. Now, the first data analytics we are going to look at is the descriptive analytics. And as we know, it is answering questions about what happened. Like in this case, we are interested in answering what was the percentage of volume distribution by average order value. In order to answer this question, what was the percentage of volume distribution by average order value? We have drawn a bar chart like this. All right. Y-axis to capture the dimensions on volume distribution, and x-axis to capture the dimension on average order value. And here we will have several bars. Each bar represented different accounts based on and it's differentiated based on different color. We have a private retail account, corporate purchase account, share community or group account, and also guest or one-time purchase account. And each of these accounts, we categorize it based on different category of average order value, right? So here we can see that, for example, based on the average order, okay, this line represents the average order value. When we average out all of these different accounts together. All right. For example, if you want to answer a question for this, for example, what is the percentage of volume distribution by average order value? For average order value in the category within 50 to 80 USD dollar, it will be 58.50. Okay, this will be the average order value for this category of order value, right? And then the second question answer under this descriptive analytics is what was the average revenue for the month of January? Here we can see we have several graph or chart shown on top here, small charts to describe the monthly revenue and also the average revenue for January. Right, we can simply use our daily transactions information in order to describe what happened, okay, using the descriptive analytics. And then for this chart, it is a map chart, right? It shows us the traffic, the geographical traffic coming to this e-commerce website. The third question that this descriptive or this dashboard describe will be what were the top product categories and traffic sources. Here, the top product, it will be winter coat, right? And then here, to answer the question about the traffic source, here we can see that 65% of the total traffic are from the mobile devices. And in general, based on what we see here, we can say that for most of the time, when we conduct our descriptive analytics, we will use table, bar chart, histogram, line graph to display, okay, the result of our descriptive analysis. Now, the difference between bar chart and histogram is that we'll use histogram if our data is interval or ratio in nature, right? In contrast, for bar chart, if our data, most of the time we will use bar chart if our data is in categorical data. For example, sex, male, female. Okay, fraudulent transaction, non-fraudulent transaction. That kind of category. Okay, categorical data. Then we look at the second type of data analytics, which is diagnostic. Diagnostic is it's very unique, but in its own, because it definitely asks the question about why. Why did something happen? For example, it may answer the question like why a specific event. Now, in this case, in this diagram, the specific event or the trend that we are interested in is the cart abandonment, right? So we want to understand, okay, by analyzing the problem of cart abandonment. We want to know what is the root cause of high cart abandonment. Here, usually before we move to the diagnostic analytics, there must be something that triggers the need for diagnostic analytics. And what triggered that is when we conduct our descriptive analytics and find that there's something alarming. For example, here, descriptive analytics here on top here, we have three graphs. This one, the first graph, illustrate the mobile versus desktop churn trend. The blue line represents our mobile churn trend. This is alarming because the churn trend in our mobile, for the customer using the mobile to visit, to transact with this e-commerce website using mobile, it is alarmingly has a high rate of churn, right? Compared to the desktop, the churn rate is decreasing, and that's good. And then in this bar chart, we can see that the checkout funnel, okay, is decreasing, right? And then here will be the meter chart to show us the overall churn risk score. Overall churn risk score is pretty, yeah, it could be alarming. All right. And then for all of the for the descriptive analytics, okay, we will tell us what we should, or is there anything further analysis that we need to do? And from here, we know that there will be more diagnostic analytics to be carried out. So you want to understand why the churn trend, okay, indicates there's a churn rate increase in mobile for traffic coming from the mobile device. So here we will start, okay, as part of our diagnostic analytics, we will do the data drilling. So we know that from here, from the descriptive analytics, we know that mobile devices you consumer is pretty risky because the channel is increasing. So we will look at the customer segment based on devices, where the transaction come from. And then from this customer segment based on as device use, we try to further do some data drilling to understand device coming from which geographical region. Is it northern region, southern region, or whatsoever? And then from this region, if we observe, if we observe that there's a technical abnormality, right? Then we can say that we have found the error. You can spot, okay, some reasons that cause this cut abandonment, right? So here, the technical abnormality found is that the iOS checkout page error. What is found is that error present on iOS checkout page, right? So we, from here, from this stage of data drilling, we find out this abnormality or anomaly. So we move on. We do further analysis. Here we can say here relation and hypothesis testing. When we do hypothesis testing, we are doing predictive. All right, but at the very early stage of hypothesis exploration, may involve starting with doing the correlation. Here we find out that, okay, I mean, in general, from the correlation and hypothesis testing, we found that the root cause, there are two main root cause. One is technical issue and the other one is behavioral issue. The technical issue is find out that the iOS update button freeze. Update caused button to freeze. As we know that in our checkout page, in our usual e-commerce checkout page, there will be some buttons, and one of the buttons is called update, which allow us to update the quantity of the product that we intend to buy. For example, originally we may intend to buy 10 pairs of shoes, right? And then suddenly we find that, oh, maybe we don't need that many. So we reduce it to maybe 1 pair. So based on this description of root cause, it seems like when the user change the quantity from 10 to 1 and then click the update button, then the whole page freeze, right? So here they find out that from this diagnostic analytics, find out that for technical reason, okay, it costs 70% of the chunk. Oh, that's very high. And then another main cause of the cart abandonment is that observe that unadvertised shipping surcharges, all right, which lead to cart abandonment. This one means that the shipping surcharge was not being advertised or not being shown to the customer upfront. It only exists or it only appears at the end, okay, when customer go to the shopping cart, okay, and is about to pay for the product. So when the customer suddenly see the surcharges for the shipping, for the logistic, then the customer will just stop. All right. So the transaction just stop there in the shopping cart. So you will have the high rate of some cart abandonment due to not well informed shipping surcharges. And then as part of our diagnostic, we I mean the further diagnostic analytics, actually we do so-called interaction analysis. How does the technical issue interact with the hidden shipping fee? All right, is there any core influence, okay, factor that caused the churn rate to be high, or that caused the yeah that caused the cart abandonment, right? And here we can see that the possible actions, right? When we do something like this, already we have some sense of, or some flavor, some prescriptive analytics flavor, right? Action, what action can be done now, right? It's like, okay, do some immediate iOS checkup button fix, right? That's one of the actions. And with respect to the second root cause of the cart abandonment, all right, which lead to possible churn, would be add transparency in the pricing strategy. It means the pricing must be transparent to the customer, or make the pricing to be transparent to the customer. And then another one, possible actions, okay, with respect to this issue, cart abandonment, will be create some system automated functional health monitoring to monitor, okay, if there's any unexpected or any real-time problem or any abnormality that happen online in this e-commerce website. Right. So this is an example of e-commerce shopping cart abandonment root cause analysis. So usually this kind of a root cause analysis, we can also use the fishbone diagram to illustrate, okay, to allow us to drill down to ask several why questions in order to identify the real root cause behind, okay, a problem that surface. And the type of display that we can use to illustrate our diagnostic analytics result, it could be line chart, bar chart, a scatter diagram, and so on. Now we move on to the third data analytics, predictive analytics, and it's answering question related to what, right? What. And when we talk about predictive, usually the answer given by this analytics will be very precise. Most of the time, it's a kind of numeric, or maybe categorical, right? Yeah. And then, I mean, in this, based on this diagram, the question answered by this predictive analytics will be, what is the probability that a customer will defect to a competitor within a specific time frame? What is that specific time frame? Actually, we don't care. All right. We simply look at this diagram. In this diagram, we have y-axis and x-axis. Y-axis is about churn rate, and churn rate has been is being rated based on a values ranging from 0 to 1, and x-axis, it is based on the customer behavior segment. All right. Here we can see we have 4 categories of customer behavior segment: highly engaged, mildly disengaged, and increasingly disengaged. Here we have 2 lines. The red line represents the predicted churn probability. Here we are making prediction based on our current base of customer. Okay, based on our current customer base, we categorize it based on these 4 categories. and we are making the predictions for each of this category of for each of this customer segment. What is its churn rate? For highly engaged customer segment, of course, the churn rate will be relatively low compared to the increasingly disengaged customer segment, right? And in this line graph, we have, based on individual company, okay, it has set the high risk of, high churn rate risk threshold to be 0.8. Any threshold equal to or exceed 0.8, then the churn rate is considered very high. It's considered high. Then that's alarming. Okay, when that such alarm exists, that such alarm message happen, all right, then do some action. The action could be what? Automated win back email, send the customer email, okay, tell them something, all right, any special offer, okay, or you provide exclusive discount code offer to this type of customer, all right. If you see that, if your company think that churn rate at 0.8, then action must be taken, then do something. The action could be any of this, or you can do what? Proactive customer service call. And then here, the blue dotted line represent predicted customer lifetime value. The customer lifetime. How long the customer will stay with you, we never know. Maybe 1 month, 1 year, 5 years, 10 years, we never know, right? Okay, but for each of these customer segment, we make a prediction for its lifetime value. All right. Value we can predict, but how long we don't know. Okay. We don't care. Okay, as I said earlier on. Okay, what's probability that a customer will defect to a competitor within a specific time frame? We don't care. But what we care about is that what is the value? Okay, during its lifetime with us. Of course, the timeline, the lifetime will end when the customer, if a customer leave our brand. Okay, well, when they leave, their lifetime value will be zero, right? So here we can see that this blue dotted line has some, because they are actually you can say contradict one another, because if your churn rate is high, then your value will be low. Okay, and then if your value is high, it means that your churn rate is low. Right? And how can we illustrate this type of data analytics? Usually we draw a regression line, right? A regression line. Here we have 2 lines here. And each lines may indicate some information, all right, telling us when is the time that we should do something, take some action A, B, or C, something like this. And then in our the fourth type of analytics is the prescriptive. Prescriptive will answer the question like, what should be done? Or what can we do to make X happen? Right? And this type of analytics usually give us an absolute best course of action. It will tell something what to do. And this action could be meant to maximize sales, profit, or retention. It could be anything. Okay, by taking into account the real-time constraint. For example, it could be what inventory level, profit margin, marketing budget, and so on. Right, and here, let us see in this diagram, the prescriptive analytics that is shown here is about the dynamic pricing and also the markdown optimization model. Here we assume that our e-commerce company is doing marketing or is selling the product to the North region. We don't care. Is it in the Europe North region or in the Asia North region or the North America region or South American region? We don't care about that. We just to simplify things, we just focus on we have an e-commerce company and its customer comes from northern region and southern region, right? So now we are looking at a dynamic pricing and markup optimization model based on our customer region and also based on our special case of cut abandonner. In this chart, we have the y-axis to represent the decision feasibility, okay, with a value range from 0 to 1, just to represent, to indicate how feasible or how workable that decision is. For this northern region, our dynamic pricing is as such. For northern region, we recommend a markdown up to 18%, right? This is the optimal action. And because we are talking about northern region, there could be several countries or several locations or branches that this e-commerce website has to cater the product or deliver or logistic thing, product logistic management to do. So in short, it means that geographic reallocation could be high. It means that product may be delivered to various parts under this northern region. That's what it meant by geographic reallocation is high, right? It means this could be a very big region. And then for the southern region, we are not going to use the same markdown optimization model. We are going to use other type of marketing strategy, whereby in order to clear the inventory, okay, the dynamic pricing that it add more budget in advertising the product. And then under this southern region, we don't have any markdown. No. All right. And yeah, we just invest more money for the budget. And then for the customer that shown some problem about the cart abandonment, then the possible strategy that that this e-commerce company is going to do will be bundle the product that this group of customer bundle the shopping cart of this group of customer with a spring scarf. Right? How this work? It could be this spring scarf could be given as a free gift, or it could be special discounts. Okay, to attract this cart abandoner to change their mind, right? But however, here we have a minimum margin constraint. So in this prescriptive dynamic pricing and markdown optimization model, the possible actions, right? Here we say that for prescriptive analytics, it goes one step further than descriptive and predictive because it recommends possible action. Okay, it recommends possible action or possible outcome. For example, okay, automated price update. For example, here we do some markdown, right? So the price may change, okay, at a slightly cheaper price, 42.5 USD dollar. Or we have the, okay, targeted bundle promotion spring scarf action. Or we may have optimized shipping allocation, right here. So this will be the prescriptive analytics. Well, we have completed this module 2, and please feel free to scan this QR code in order to try our online quiz on data.